Welcome to the DIY Honda Garage channel. DTC P0238 refers to a fault in the turbocharger boost sensor circuit, indicating a high voltage condition. This diagnostic trouble code, or DTC, is primarily associated with the operation of the turbocharger boost sensor. The turbocharger boost sensor plays a crucial role in measuring the pressure of the intake air that is boosted by the turbocharger. This measurement is vital for the engine control module, ECM, to optimize air-fuel ratios and overall engine performance. The sensor is typically located near the turbocharger itself and is connected to the powertrain control module, PCM. Monitoring the voltage signals generated by the sensor enables the vehicle's onboard diagnostic system to ensure the turbocharger is functioning properly. If the voltage exceeds the normal operating range, it can trigger DTC P0238 and indicates an issue that requires attention. Error P0238 indicates a high voltage condition in the turbocharger boost sensor circuit. The turbocharger boost sensor, integral to the turbocharging system, provides critical data regarding the air pressure in the intake system to the ECM. By measuring the boost pressure, this sensor aids in optimizing engine performance. The typical location of the turbocharger boost sensor is directly on or very close to the turbocharger unit, allowing for accurate readings of the pressure it senses. An abnormal voltage reading, specifically measurements exceeding 4.49 volts, can lead to triggering this DTC. The PCM relies on the accurate data from the turbocharger boost sensor to maintain engine performance and efficiency, making this a crucial component within the engine management system. Several possible causes can lead to DTC P0238 being triggered. First, wiring issues such as frayed, corroded, or damaged wires can result in high voltage readings, affecting the signal delivered to the PCM. In addition to wiring, connector faults may also play a role. Loose connectors or poor connections at the turbocharger boost sensor and PCM can disrupt signal integrity. A malfunction of the turbocharger boost sensor itself is another significant cause. If the sensor is defective or internally shorted, it can present erroneous voltage levels to the PCM. Lastly, other components in the signal path, such as the engine control module, may contribute to this issue. Each of these potential causes warrants thorough investigation to ensure the integrity and functionality of the system. Symptoms associated with DTC P0238 can significantly affect vehicle performance. One of the most immediate indicators is the illumination of the check engine light, alerting the driver to a potential issue. Additionally, drivers may notice poor engine performance, such as reduced acceleration or improper engine response, which can stem from incorrect air-fuel ratios caused by inaccurate pressure readings. Furthermore, high emissions levels may occur as a result of overboosting or underboosting conditions, leading to an increase in harmful exhaust emissions. It is crucial for drivers to pay attention to these symptoms and take action promptly to avoid further complications or damage to the engine components. The first step in troubleshooting DTC P0238 involves verifying the current conditions of the turbocharger boost sensor. Begin by turning the vehicle to the on mode and utilizing the Honda Diagnostics System, HDS, to check the TC boost pressure sensor's voltage reading. The threshold for proper functionality is a voltage of 4.49 or more volts. If the current conditions match this threshold, proceed to the next troubleshooting step. However, if they do not match, this indicates an intermittent failure. It is essential to investigate the integrity of the wiring and connections to both the turbocharger boost sensor and the PCM. Look for any signs of loose terminals or poor connections. This initial verification step sets the stage for a methodical approach to diagnosing the root cause of the DTC. In troubleshooting step 2, the aim is to isolate the turbocharger boost sensor as a potential source of the problem. Start by turning the vehicle to the off-lock mode, then disconnect the turbocharger boost sensor's 3P connector. To test if the sensor is functioning, connect a jumper wire between terminals A and B of the connector. After making this connection, turn the vehicle to the on mode again and utilize the HDS to observe the voltage at the TC boost pressure sensor. If the measured voltage is about 4.49 volts or more, this suggests that the circuit leading to the sensor is working correctly, and the issue may lie elsewhere. If the voltage does not meet this threshold, it indicates that the turbocharger boost sensor may need to be replaced, as it cannot provide the appropriate signal. The third step in the troubleshooting process focuses on checking the voltage across the turbocharger boost sensor circuit. Begin by turning the vehicle to the off-lock mode and removing any jumper wire previously connected. Next, with the turbocharger boost sensor 3P connector still disconnected, turn the vehicle on and measure the voltage between test points 1 and 2. Ensure your measuring device is appropriately calibrated to check for approximately 5.0 volts. If the reading is successful, this confirms that the SG2 line, which is responsible for sending signals from the sensor to the PCM, is functioning as intended. In case the reading deviates, further investigation will be needed, likely suggesting issues with wiring or connectors to that line. In troubleshooting step 4, the objective is to perform an open wire check on the SG2 line to ensure there are no interruptions in the circuit. Begin by turning the vehicle to the off-lock mode. Then jump the SCS, System Configuration Select line, using the HDS, and wait for more than 1 minute to prepare for testing. Disconnect the PCM connector E, 80P, to facilitate the continuity check. With both the turbocharger boost sensor 3P connector and the PCM connector disconnected, check for continuity between test points 1 and 2. If there is continuity, it indicates that the SG2 wire is intact, suggesting that any issues may stem from other related components. If there is no continuity, repair is necessary to address the open circuit in the SG2 wiring between the PCM and the turbocharger boost sensor. The final troubleshooting step involves conducting an open wire continuity check for the P3 line, which is vital for the turbocharger boost sensor's operation. As before, begin with the vehicle in the off-lock mode and utilize the HDS to jump the SCS line again, allowing proper conditions for testing. Disconnect the PCM connector E, 80P, to enable the analysis of the circuit. With the turbocharger boost sensor 3P connector still disconnected, you will now check for continuity between test points 1 and 2. If continuity exists, it confirms that the P3 wire is functioning correctly. Conversely, if continuity does not exist, you'll need to restore the connection by repairing any breaks found between the PCM and the sensor. Once the integrity of both wiring paths is confirmed, further diagnostics can be completed or a known good PCM may be substituted if issues persist. After completing the necessary repairs and troubleshooting steps, final verification is vital to ensure the DTC P0238 has been resolved. Start this process by resetting any diagnostic trouble codes using the Honda Diagnostic System, HDS. Following this, run the engine for an extended period to simulate normal driving conditions while observing the voltage readings from the turbocharger boost sensor. If the sensor shows operational values within the expected range and does not trigger the DTC, this confirms the repair was successful. Additionally, a road test should be conducted to make sure that all symptoms related to the DTC have been cleared and that the vehicle operates efficiently. This final verification step is essential in preventing future issues and ensuring the reliability of the repair work performed. Preventive maintenance is crucial in avoiding recurrence of DTC P0238 and ensuring the longevity of your vehicle's turbocharger system. Regular inspections of the turbocharger boost sensor and its associated wiring and connections can help identify potential issues before they escalate into larger problems. Additionally, maintaining clean and secure electrical connections will promote better signal integrity and performance. Keeping an eye on engine performance metrics can also help catch early signs of malfunction, allowing timely intervention. Implementing these preventive measures not only aids in the smooth functioning of the turbocharger system, but also enhances overall vehicle reliability. Drivers should engage in these regular practices to enjoy optimal engine performance, efficiency, and longevity. In conclusion, understanding the intricacies of the turbocharger boost sensor system is essential for effective troubleshooting and repair of DTC P0238. The turbocharger boost sensor plays a vital role in optimizing engine performance, and recognizing potential issues early can enhance the driving experience. This DTC primarily points to high voltage in the sensor circuit, gaugeable through systematic troubleshooting methods detailed in this guide. Ensuring the integrity of the wiring and connections throughout the system must be emphasized, as several issues stem from this area. Lastly, routine maintenance and inspections serve as the best avenue to mitigate future problems. By adopting these practices, vehicle owners can maintain their excited driving performance and avoid unnecessary repairs. Please like and subscribe to the channel. See you next time.